Hello students, this is Meenakshi Rao here. This video is meant for BBA students of University of Mysore. The subject is Business Decision Statistics 1, meant for 5th semester, and the topic for the discussion today is Carl Pearson's coefficient of correlation. So in this problem, we will see how to calculate probable error. So in the previous session, we have seen that when bivariate frequency table is given, how we are supposed to calculate the coefficient of correlation. So with the help of coefficient of correlation, we will be calculating the probable error. So what is probable error? Coefficient of correlation is given by the study of samples, but sample correlation coefficient need not be equal to the actual value. In such cases, with the help of probable error, it is possible to determine the variation between reliability of coefficient of correlation and sample coefficient of correlation. So, probable error measures the extent to which the correlation coefficient is dependable. It is an old measure of testing the reliability of R. So, probable error is given by the formula, that is PE is equal to probable error is equal to 0.6745 into 1 minus R square divided by root of n. So what we need is R. So first we should calculate correlation coefficient and then the number of pairs of observation. So interpretation of probable error. If the value of R is less than PE, the value of R is not at all significant. It will be insignificant. If the value of R is more than 6 times, the value of R is significant. So if it is significant, it is very good. The value of R is significant. So let us see one problem here. Calculate Carl Pearson's correlation coefficient from the bivariate frequency table given below and also determine probable error. So how to calculate correlation from the bivariate frequency table I have explained in the previous session. Here already I have calculated the values. Now just today in this session we will apply the values to the probable error. Now after calculating, we have got these values. Okay, we have got these values. I have explained the method how to calculate in the previous session. That is, on the right of the problem you have to draw 6 columns. One is frequency, midpoint of x. You have to find out dy, f dy and f dy square, that is dy into f dy, and finally you have to dy into dy, and finally you have to calculate f dx dy. Similarly, below the rows you have to write 6 columns and calculate the similar type of values. Now once we calculate the values, we should apply the values to the formula. So after that we will come to know that R is equal to 0.716. Now based on this R, we have to calculate the probable error. So what is important is we will calculate the probable error. Since I have discussed in detail how to calculate the correlation in the previous slide, you can watch the previous session slide for more details. Now probable error is nothing but PE is equal to 0.6745 into 1 minus R square divided by root of n. So PE is equal to 1 minus 0.716 the whole square divided by root of 19. So you will get the following values. Okay, after simplifying further, you will get 0.49 divided by 4.34. After simplifying it, we will get 0.11. So into this. So P is equal to 0.074. So since R is 6 times, since R is greater than 6 times the probable error, that is 0.716, that is R, okay, is greater than 0.444. That is, how we got 0.444 is nothing but 0.074 into 6. We should multiply that. So we will get 0.444. Now 0.716, that is the correlation value, is greater than the 6 times the probable error, then we can say that R is highly significant. So to conclude, we can say that probable error is applicable only when the number of items is large. However, if R is greater than 6 times the probable error, the R is highly significant. The books which I have referred for this problem is all these books, and you can also refer these books for advanced problems. Thank you for watching this video.